Calorimetry is part of instructional segment 1, which is on combustion. Uh, Instructional segment 1 deals with the law of conservation of mass, law of conservation of energy, and also calorimetry problems. So for the law of conservation of energy, the law states that energy can neither be created nor destroyed, only converted from one form to another. Say, for example, you have the burning of a match. In the burning of a match, you have chemical energy, okay, from the match itself, and then it's turned into thermal energy. It produces heat, plus light energy. So you can see there's the flame that produces light. For these problems that you are going to solve today, you must do them in dimensional analysis. Dimensional analysis involves 3 steps: analyze, solve, and evaluate. When you analyze a problem, you are to write down what's given, including their units, and if ever they're given a symbol like M for mass, a C for specific heat, and delta T for change in temperature, you have to write them. Write also the one that is being required. Then after that one, you have to solve it. If there's a formula, write down the formula. Say, for example, the formula is Q is equal to MC delta T, or Q is equal to M cut. Show the work and then write your answer with the correct unit on it. And then finally, you are to evaluate your answer. Does it make sense? Did you write it in the correct unit, in the correct number of significant digits? Did you have the right unit for it? So those are the questions that should be asked whenever you're doing dimensional analysis. So let's now try this problem on the law of conservation of energy. So an unlit match contains approximately 1000 joules of chemical energy. When it burns, the match releases thermal energy and light energy. So that's why you have the formula here in where you solve it. Where's the formula right here? Chemical energy is equal to thermal energy plus light energy. Okay, and then you are to write down what's given. You're given the chemical energy of 1000 joules, and then it says right here that there is an amount that is not burned. It's a total of 205 joules. And then um, it produces thermal energy, which is 516 joules. How much light energy did the match emit? So you write the light energy under required, and then now you have to solve it. But how much energy is used? Okay, so it should be the chemical energy, which is 1000, minus unused chemical energy is 205. So total is 795 joules. That is the one that you should plug into the equation right here. So chemical energy equals 795. Then how much thermal energy do you have? Okay, the one that's given is 516, and then you are just looking for your the unknown, which is light energy. Okay, so you plug it and you actually do isolate light energy, and the conventional way of writing your equation is you write your unknown on the left side of the equation. So therefore now you have 795 minus 516 is equal to 279 joules, which is the answer for the problem. Okay, let's go to the next, which is the application of the law of conservation of mass. So according to this law, during any physical or chemical change, the total mass of the products remains equal to the total mass of the reactants. So in this one, okay, so the reactants are on the left side of the equation. So calcium oxide and water are reactants, and then the product is your calcium hydroxide. So you have here a chemical reaction, and the chemical equation shows how it looks. Okay, most of the time it will be written in formulas. Like this one is not. So calcium oxide should have been CaO, and then water should have been H2O, and calcium hydroxide should have been CaOH. But anyway, just to give you the information, like the total mass of the reactants, which is calcium oxide plus water, uh, plus the mass of water, must always be equal to the mass of calcium hydroxide, and that is what the law of conservation of mass tells us. Does it apply only to chemical reactions or chemical changes? No. It also happens when you have a physical change like melting of ice, um, evaporation or boiling, freezing of water, condensation, sublimation, and deposition. All of those are just changes in state of matter. So, like freezing of ice is from, freezing of water is from liquid to a solid. Melting of ice is from solid to liquid, and so on. So those also applies. So when you boil water, and say initially the weight is 100 grams, and then after a few minutes you weigh again, and it will just say, for example, weigh just about 70 grams. You know that the 30 grams that was lost was turned into H2O gas or water vapor. Okay, let's have a problem here on that particular one, which is the law of conservation of mass. You're given those, so you have to write down your given for dimensional analysis. The mass of calcium oxide is 27 grams. The mass of calcium oxide unreacted is 2.3 grams. The mass of water is 15 grams. What is being asked? The mass of the product, which is calcium hydroxide. So this is, you just use your formula for this, and then what do you do? 27 minus 2.3, okay, which is the mass of calcium oxide, plus 15 is now equal to 39.7, and whatever the mass of calcium oxide is in mass of water, that will be the mass of calcium hydroxide. How is it again? How did you get the mass of calcium oxide? That was used right here. The mass of calcium oxide is equal to 27 grams minus 2.3. Okay, and that should be about 4.7. Okay, and that is what you add to 15 grams, so that makes 39.7 grams. Okay, let's go to the next, which is an example of calorimetry problem in which you're not given a word problem, you're just given information. And then this one is easier. Okay, so you just plug it into the equation, which is Q is equal to M cut or delta T, and then you have 25 grams of your um, 25 grams is given of water. Okay, and then you have the specific heat is 4.184 joules per gram degree Celsius, and you have final temperature 27.3 minus 25.0, and don't forget the units. You cross out the grams, you cross out the degree Celsius, and what's left is the joules, which is the unit of Q. Okay, just remember that when you do dimensional analysis, okay, you should always like write down given required. Okay, for solve, you have to write down the formula, the work, and finally the answer. And make sure you cross out anything, any unit that needs to be crossed out, so you'll come up with the answer.